Hello friends, so welcome in the new video. In this video we will going to see how to interface another hardware which is EEPROM with our Nucleo-144 board. So this time again I am coming with Nucleo-144 board related experiment which is STM32, and this is the EEPROM. So this is our second part, I would like to say, because in first part we have already seen how to find the address of unknown device. So we are using same device which is STM32CubeIDE, which is EEPROM. Connections are like with STM, SCL is connected with SCL, SDA is connected with SDA, ground with ground, and 3.3 with VCC. For this I2C pin connections, I have used these two pins PB8 and PB9. So this here you can see the screenshot. I will not going to configure this step by step, otherwise this video will having very long duration. That's why I just showing you the snapshots or screenshot of the configuration part. So you can see here two pins are there, PB8 and PB9, both are having I2C pins configuration like SCL and SDA. And on board, if you can see that this header is having these two pins, so you can simply go on internet and find the pin connection, pin diagram of Nucleo-144, and you will find that PB8 pin is somewhere over here and PB9 somewhere over here. So skip first pin, and second and third will be the pin for this. So you can see I am just use simply jumper wire, and power supply is also provided from the board only. That's why you can see this LED is on. Okay, so these are the connections. Now before moving on the writing part, let us understand the logical structure. So consider this EEPROM as a simple white paper. So just take one white paper with you, draw different number of lines. So for this example, draw total 1024 rows, let us say. So on one particular paper, let us say 1024 rows are there, and each row you can write something. Okay, and for simplicity, let us say you can write only binary things, 1 or 0, digital message, right? 1 or 0. Now if the rows size is 8-bit, it means only 8-bit you can write in particular row, not more than that. You can write less, but in that case the size will be unutilized. So let us say for each row you can write maximum 8-bit, and you have a paper with you having 1024 rows. So you can say total 1024 into 8-bit you can write 1024 into 8 bits you can write in this paper. Now let us convert this 8-bit into byte. So we all know that 8-bit is equal to 1 byte. So if you will consider this page as an EEPROM, then size of this EEPROM would be 1 KB, because each row is having 1 byte, and here 1024 addresses are there. So 1024 bytes, and if you convert this to 1024 bytes into kilobyte, then it's a 1 KB. Now let us say you have 1024 pages with you, then size will be 1024 KB, or you can say 1 megabyte. Okay, so if you have 1024 pages, then size would be 1 megabyte. And to convert this megabyte into bit, this is capital B, and if you want to convert this megabyte into bit, then simply multiply this number with 8. So for simplicity, if you have a single paper, so size is 1 KB, and if you convert this into byte, so 1 KB into 8, so approximate value would be 8 kilobits. So the size of this EEPROM would be 8 kilobits. Now in this experiment we will going to write some message on this EEPROM. Now you can see here each EEPROM is having different number of rows, and each rows can have some capabilities, like 8 bits something. So if I want to write this message hello, so how can I write this? So we all know about the ASCII. So each character can represent as a hexadecimal number, right? So for simplicity, let us assume that each character is having some number. They are actually, each character can be represented as a number. In ASCII, for example, small a can be represented as a 97 if I am not wrong, right? Same way, each character is having some fixed hexadecimal number. So if I want to write this hello message on this EEPROM, so each row will occupy one character, H, E, L, L and O. So total 5 rows will be occupied by this message hello, or you can say 5 bytes will be occupied by this message. Now in future, if you want to write something else, something other messages, then you have to skip these first 5 lines. So let us say if you want to write hello world, so now W should start from address 5th only. If you will write this W in any of this address, then the message will be simply overwrite. So now instead of hello, it will be HWLLO. So you have to make sure that whatever message you have written in your previous run, your next message should be incremental, on incremental address only, right? Not on a same address, otherwise you will miss the message. Your message will simply overwrite. So this is the logical structure of EEPROM. Now in this video I will not going to configure the board and write the whole code. I will simply explain you the code. I will put this code in the description box of the video, so you can simply download the code. Okay, so I have divided this code into 3 parts. First is a declaration part, second is a function explanation part, and third is our actual program. So in first initialization declaration part, I am just declaring our I2C address of the device. So as you know that in my I2C address finding video, I found that the address of this device is 80. When you convert this 80 into hexadecimal, it will be 50, 0x50. So our address of the device or the board is 50. This is the message. I have declared 2 different variables. First variable is tx data, so I am simply loading my message into this variable. Second is my rx data, and on rx data I am just simply storing 0, but I will make sure that the size of this rx data would be same as the tx data, and that's why you can see it's an array, but the size of the array is size of the message. So in future I will going to read this message using this variable only, so I can have exactly same message, same size message. So this first 4 lines are there for the defining the address, message and 2 variables. Now second and most important part of this video is 2 functions, because once you have these 2 functions declared with the program, you can simply call those functions and write anything and read anything from the EEPROM. So you can see both functions are having same type of argument. First function is write EEPROM, second is read EEPROM, and in both the functions we have 3 arguments. First is a mem address, second is a data, and third is a size. Same way here read EEPROM also having 3 arguments. Now what is mem address? So one thing is the device address. Now in the device, as I explained you earlier, that you can consider EEPROM as a page, and each page having number of rows. So I am talking about this address, right? Memory address, on which particular location you want to write something. You have the chip with you, you know the address, but on which particular location you want to write, that you have to define over here. So write EEPROM function is having 3 arguments: address, data and size of the data. So you have to specify on which particular address you want to write, what you want to write, and what is the size of the data. That's it. Same way read function is also having same argument. Now inside the write function, first thing is I am just checking this with the if loop. If HAL I2C mem write is not equal to HAL OK, then it will execute this, otherwise it will execute this. Now what this function is doing, HAL I2C mem write, so this is actually HAL function, it is inbuilt function, and you can see 7 arguments are there. First is the handler of I2C. So if you declare the I2C, you will have this handler with you. We have seen this in many of our program previously. Second is the address of the device. Third is the address of the memory. Fourth one is the address size. So I am using 16-bit address size for this I2C, right? And for the both write and read, this is same. You can see this is same. Okay. Now next argument is data. Whatever data you want to write, then size of the data, and this 1000 is actually a random number, you can say. If your message is long, then you have to increase this count, otherwise this function will time out after this much tick, you can say. So this is just a timeout period, you can say. And if this function will execute successfully, it means that if the device is present, if the address is perfect, and if this message will write the data into the I2C, it will return HL OK, and in that case it will execute this. Okay, and if this will not return HL OK, so let us say if device is not present, or if address is not same, or if address is wrong, whatever reason, so it will simply execute this. Now here two sprintf functions are there. So in first, upon successful execution, it will write message return and your data. It will write this into UART buffer, and if there's some issue is there, and if this function will not write successfully on the EEPROM, it will simply load I2C transmission error in this variable. Okay, so let us consider the successful case. If the memory is present and if this device will write successfully, so it UART buffer will having this message return your message, and this is the common part. Okay, in successful case or in unsuccessful case, this UART will display the message. So if the operation is successful, then UART will display message return, then your message, and upon unsuccessful, it will simply print I2C transmission error. Same way in read, you can see arguments are same, but this time we have HL I2C mem read function. Again here same 7 arguments are there, but this time we will not pass anything in the data, but here we will pass variable where we will going to read something, where we will going to read the data from the EEPROM. So this data will store the read data, read message, you can say, right? Size will be specified, but this data will loaded with the content of the EEPROM, right? It's a reverse thing. Now again, upon successful execution, it will simply load this message received, and whatever data it will receive from the EEPROM, it will store all this thing into UART buffer, and it will display on UART. Upon unsuccessful execution, it will display I2C reception error, right? So if your message is hello, and if the overall process will execute successfully, then you will see message return hello, message received hello, simply, right? So these two functions are there, and now finally our program. So you can see program is having first argument, second argument, third argument. This is just to display something on UART to make sure that our board is working, our UART is working. So even if the I2C is not properly configured, we can have some idea that okay, our program is working properly and we have some issue with the I2C. So that's why I'm just printing something, starting EEPROM test on UART. Okay, and I'm using UART 3. Now next function is write EEPROM. So I'm writing on 00. This is message, size of the message. Our message is, this is testing by hardware coding. Then after some delay, I'm reading something from this address. This is the variable, as I told you earlier. So it will simply print something on UART, right? We all know how this function will work now. So this is the code. Okay, now let me show you the actual code in our STMCubeIDE. So this is the pinout view. So you can see here I simply configure I2C on PB8 and PB9 pin. I have configured UART on this PD8 and PD9. Now I have configured UART3. Why? Because on Nucleo-144 board, onboard UART is available. So if you will simply use this UART3, then directly using the cable you can get the data on serial port. So I have not used any other interface. I directly connected the Nucleo-144 board with my PC. I will show you this, and I can get the data. So let us start this. So here you can see this is the board. I connected this with the wire. This, if you will send anything on UART3, you can simply send over here. So via this wire it will receive in your laptop, and on serial port you can visualize this thing. So for that I am just opening the putty. Okay, now serial. Now I know COM port 4 is there, and in this program also you can see our baud rate is 9600. Okay, so now this is the program. You can see I will put this program in a description of this video, so you can simply use it as it is. So here I2C address, message, TX data, RX data, then these two functions as it is, as I already explained you, and then this is the main program as it is, right? So now I am just simply releasing this target, so it will generate the updated hex file. Now I will load this on the board. From this LED you can see the program is currently loading on the board, right? And I'm just opening this COM port 4 after successfully uploading this, and now I will simply press the reset, and you can see we have the message starting EEPROM test, message returned this is testing by hardware, and message received this is testing by hardware. Okay, so you can see whatever we are writing, we are reading it back. Now for more understanding, let us change the address of the received read EEPROM. So now I will simply update this address from 0 to 01. So as we discussed, now I will going to read my second row of the page. So first row would be the message starting character, which is T, but now it should read from the second character, from H. So now let us upload the program on the hardware, check the putty, and now you can see we have this skip character. Let us press this reset again and again, and you can see each time we have the message, but now we don't have this T because I increment this read address by 1, incremented this read address by 1, so that's why it is keeping this first character. So this is how you can interface EEPROM with the board. This is simply, I am just writing message. You can use this for your IoT application. You can write the value of some temperature sensor or whatever. You can even store the image, right? You can store the pixel value, you can store the sensor value, everything. So this is what for the today's video. In future I will rearrange the playlist, so for a student who is not familiar with this, they can also having simple flow starting from the easiest thing to the complex thing. So I will make sure that within a few days I will rearrange the playlist if it is possible for me. This is what for this video. If you like my work, please like my YouTube videos, subscribe my YouTube channel, share with your friends. Thank you very much. Thanks a lot.